Okay, on this slide, we're going to do 32 through 37. So 32 is the S wave. That is side to side. The P wave is fast. It travels through solids and liquids. And the surface wave causes the most destruction because it is right on the surface. So the P wave is first, the S wave is second, and the surface wave is third. All right, so how do we know how strong the earthquake is? You can actually look right here on this diagram. So you see this high peak right there and this low peak down at the bottom. Let me make this darker so you can see it. The stronger the earthquake, the higher and lower that line will get. So it will be like let's say if it was just like this, that wouldn't be a very strong earthquake. A really strong one might be like Number 38. Where do most earthquakes occur and how often? They occur on plate boundaries. So all the lines in this picture you see here are where the earthquakes happen. They happen all of the time. And on this image, anywhere that is red, that's where they have the most frequent earthquakes constantly. Okay, 39 finally brings us into what we've already been talking about for like the last month and a half, which is climate. So what is climate? It is the average temperature and rainfall for a given area at a given time. The reason I chose this picture is because you think of the hottest places on Earth, you think of Africa, South America, Australia. So Australia is showing to be the reddest right there. Africa also has some pretty warm areas, but South America is looking even hotter than Africa. And of course, here up in the northern and southern poles, things are pretty chilly. So you also could say our climate is based on our longitude, how far north or south we are of the equator, but it also is determined by our rainfall. So there's more than just that. All right, so temperature and rainfall determine climate. All right. Greenhouse gases are released into the atmosphere in two ways. Provide a list for the ways gases are emitted both naturally and by humans. So two natural causes include volcanoes and the circulation of oceans. You also can have plate tectonics on this list. We'll come back to that. Humans, burning fossil fuels is a huge one. So that's burning anything that releases carbon dioxide into the air. Burning coal is the biggest offender. Also for transportation, we burn oil and gasoline. So we also reduce emission, or we contribute more emissions by doing that. We also have high energy uses, and so anytime we want to create energy, we have to burn fossil fuels. Is that true? Do you think that's the only way we can create energy? It's really not, because we have alternative forces of energy such as solar, wind, geothermal, electric cars, and that's all coming through now with new technology. So a couple of the things I listed while I was busy talking is waste. So we actually contribute to carbon emissions through our garbage. Back on the natural side, you have plate tectonics, as I said, and also solar cycles does naturally affect. What do you need to know for your actual test? You probably want to know that and nothing else, but I made you listen to it all anyways. So the two that are on your test are volcanoes and ocean circulation. So just what is global warming? It is a gradual increase in the overall temperature of the Earth's atmosphere. It is generally attributed to the greenhouse effect, caused by increased levels of CO2, CFCs, and other pollutants. So the greenhouse effect is what causes global warming. The greenhouse effect doesn't have to cause global warming, but because of human input, we believe that it is causing global warming at a faster rate than it should be and to a hotter point than it should be. All right, 42, I'm taking off the test because I feel like it's redundant. So we're not going to do that question. I'm not putting it on the exam, and you're welcome. 43, what occurs during an El Nino? I wanted to get like actual written text on this for you guys because I know we never got to discuss it in class. You only did the worksheet. So Here's what it says. During an El Nino, the trade winds weaken in the central and western Pacific, that is off the coast of California. Because of that, surface waters off South America warm up because there's no upwelling of cold water from below. So nothing is coming up from below to cool down the surface. So the surface of the water is getting warmer and warmer. The clouds and the rainstorms associated with the warm ocean waters also shift towards the east. So because the water is getting warmer, you have warm water and warm air that pushes over to the United States. So we like El Ninos. They mean we get a nice, awesome, warm winter. We actually had an El Nino this year, and that's why we didn't have as much snow as we normally would have. So when your test asks you what is associated with an El Nino, it's about the warm water because the cold water can't get up to the surface. The warm water is what causes warm air. All right, you guys, we are almost done. Let's go to 44. Which greenhouse gas is most responsible for increasing global temperatures? I hope nobody gets this question wrong. CO2, CO2, CO2. 45. How do greenhouse gases affect incoming solar radiation? What does it do to Earth's temperature? So here in the, I can't find a pointer. Here in the middle layer, whoops, up here in the atmosphere, you have all these gases. You have oxygen gas, you have nitrogen gas, you have CO2, H2O, and methane. All right, so I'm going to erase that so you can see what it says. All right, so all these gases, what they do is they take this sunshine that is coming in and they absorb it. And when they absorb that sunshine, it gets nice and hot. And some of it gets reflected out, but not all. And then there's also heat that comes from all the sources on Earth, like people and parking lots. You know, parking lots create heat. And all that heat bounces back up, and it causes that atmosphere to have more and more gases to trap the heat and trap the radiation. And that's what causes the temperature of the planet to heat up. All right, last one, 46. How do volcanic eruptions affect incoming solar radiation? So there's two things that can happen here. I want you to pay attention to this because not a lot of us understood this. So the first type of thing is carbon dioxide, CO2, in the blue down here. CO2 released absorbs sunlight and warms the atmosphere. So if we have a volcano that releases carbon dioxide and water, it's okay, it's going to warm up the planet. That's not good, actually. It's not okay. If we have one that releases sulfate aerosols, remember this comes from sulfuric acid that gets released from the volcano. These will reflect radiation into space. They will completely block that radiation from hitting Earth, and it will cool our atmosphere. So a volcano's impact completely depends on the gas that is released. When you're taking your final exam, pay attention to what they're asking you for that question. Okay, when I went through the final exam, I did find one extra bit of information that was not on your review sheet, so I wanted to make sure you have it, put it at the end here. It will be on the test. So this is talking about the shadow zone and the P waves and the S waves in an earthquake. So remember that if you have an earthquake that occurs, let me get a color here. You have an earthquake that occurs right here. Right there. Okay. So noting in the bottom right-hand corner of the picture, you have a little key, and it shows you the P waves are yellow lines and the S waves are black lines. Remember, the P waves are strong. They can go through anything. So note those yellow lines. They are going away from the epicenter. And once they reach the center, the core, the inner core, and the solid inner core, the P waves do go through the core. They just get a little bit bent. The black lines represent the S waves. Those are slower. They move side to side. They don't have as much energy. They lag behind the P waves. Those don't have enough energy to move through the outer core. So there's a shadow zone, an S wave shadow zone, in which you would get no S waves moving through the center part of Earth. If you look at the right, the bottom where it's got a bunch of words, it says, due to refraction, one can get a detailed visual of the internal layers of the Earth, much like that of an ultrasound to see a baby. The shadow zone of the S wave and P wave provide the boundaries for calculating the size of the outer core. The time of the arrival of P waves proved the density. The lack of S waves provides evidence that the outer core is a liquid. All right, so for the essay, I don't want you to do question number 4 because we really didn't go through that in enough detail for you guys to be able to be tested on it. So for essay, you're going to do numbers 1 through 3. All right, so I'm not going to go through them because it's basically your exact project repeated. Okay, so you don't need any help with that. You just finished that project. You should be all good. I'm just going to go ahead here and tell you good luck. And we will miss you, and we hope you do really well, and we can't wait to hear about things that are going for you in your futures. Keep in touch.